Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux with the operating system. It's connected to a serial cable via the Serial Pi Plus board, which is stacked on the Raspberry Pi. Also connected is HDMI cable for connection with this monitor, which is currently standby. And also connected to a covered network cable for VNC to 4 VNC terminals, and via band cable connected to this breadboard with some electronics as well as a fischertechnik LED, phototransistor and motorized propeller. Also running via VNC is this Android tablet, one terminal ready to receive input, and with, let's see if I can get it. Not always easy to get things working in here. It's a challenge, but I like challenges. Another VNC terminal is active via my Mac, which I can't show you right now, but it's active. Last time I had to make a few fixes. First of all, wiring turned out to be wrong for some reason, and I had to fix here some things. So now when I use a bash program to access the GPIO, it should work. I had a problem with the GPIO class because ROS demands either Python or C++. Python didn't work out for some weird reason, so now the attempt has been for some time for C++, which happens to be my very first experience in the past as well using ROS, and that doesn't work out yet. So prior to this episode, in preparation, I looked at the way that how I used the GPIO class previously. That was on the Raspberry Pi 1 with LED testing and trying. And GPIO class needs a main. It needs an executable program to be used with. And that is easy to do with the G++ compiler, which is a version of the GCC compiler. But in this project I'm not using the GCC, I'm using CMake, or more appropriate, Catkin make. And last time I already tried to adjust the settings in CMake listed text, because everything is set with compiler, etc. But I got errors. So right now let's first see how the GPIO is going to work out. And let me try to use the tablet for this. And there goes my, for some reason suddenly my desktop on the tablet goes away. I have it back. So let's go here. Oops. No, I don't need two of them. I need one keyboard. That is a keyboard. So now I am going to the GPIO text, bash, here we are. So I start it and then have to turn the camera towards the breadboard. Here we go. That's a LED, and the motor jerk. Let's do it again. Oh, and an error on here, it says 0 and an unknown value in the GPIO text. Okay, I'll have to fix that. But first, let's go again. Yep, this works. And here something doesn't work. That's a wire issue, I think, I hope. Let's do it again. And now everything works. So now with pressing at least some input of the button, let's do it again. Yeah, not quite as I expect. One more try. And go. No, to no avail. Okay. Anyway, at least the wiring is now correct. I know the GPIO is correct because otherwise it wouldn't work. But now for the software. So let's take a look there. Alright, now the first thing to check, apart from this Minicom terminal, and let's name it if it is possible. Yep, that's Minicom. Very good. Okay, let's first check if ROS still runs. ROS core is running. So control should run, motor should run, where this is the source code of the motor control and this is the source code of the motor, which doesn't do anything yet. Anyway, this is, oh, nice to see, this is 145 and 145 was here, so it's already sending a lot and this is not receiving everything yet. Let's do it again. It's not doing anything now. Let's do it again. See, it misses the first two. So if I stop this one now, it immediately stops at 92. Okay, no problem. That's good. Then what I was talking about is the GPIO class. The C++ file has no main, so it needs another program to have a main. That will be a control file. So actually what you want is something like this. GPIO class.cpp. Then you have ft control.cpp with output output ft. Let's make sure I do that right. Yes, ft control as an output. This is what you should be able to do. But and it has no sense to do this. Oh, you can do this right here because this has a main as well. But the most logical thing is to do it here. Or is it? Actually, it's a doubtful thing, because let's walk this down. Here you only publish messages. Here you control the motor. So in that perspective, I should put this in here to have a main. However, this is not done for ROS. You should do something in here, which I already did. If I go entirely down, I come to see here, and this gives control, motor and GPIO class. Well, considering this sequence, I should put this right at the first. That said, or having said that, whatever, how can I put that in that can make that it really works? All I did so far was failing. So with this in mind, can I translate it into this one? And at times you are probably acting too difficult, because I'm looking at ROS.org again, how to define GPIO pins in ROS on a Raspberry Pi 2. Well, I could have asked that, except that this question is already 2 years old. No, almost 3 years old. And they say, well, why not use wiringPi? And yeah, that is a familiar library which I've used before. So let's go there and then see how I can use this one in combination with ROS, because with other programs I have used it, not with ROS yet. So if this helps, I can forget about my GPIO class, and hopefully things start to work. So this is a very familiar website, for me at least. So I have to probably follow everything like this. And oh yeah, this is with Raspbian. I am not using Raspbian, I'm using Ubuntu. Although Raspbian is a Debian derivative, as is Ubuntu, things can be quite different. So I am going to try anyway to install this and see how it works out. That looks to me like the way to go. Plan B maybe even better, but no, I'm going to plan A and install it and see how that works out. Following this tutorial on how to install wiringPi, I am upgrading or updating my Raspberry Pi, which also implies updating ROS packages. I've installed the Git core, and apart from that I should have stuff installed, and I do it via the serial terminal. Not that I use serial connection to upgrade, but I am using it to give the commands. Otherwise I would be using this, but I'm not that I want to leave that the same. So right now it's this environment, and this may take a while, so we'll see in a bit. So with this freshly installed driver library, actually I have to use -L wiringPi, and that is for a normal G++ compiling. So the question is now, how will it work in my case? Well, it is a library, and no matter if it's going to be here or here, I can scratch this one out. So here as well, I can say get rid of this one. Where to go from here? These are all libraries, of course, header files. What do I have in here? A lot of header files, and wiringPi is one of them. Now let's take a look at this part right here, with all the other stuff. Dependencies, standard message, but this is a ROS dependency. Packages, also nothing. Include directories. Those are, I don't think that these are necessary. Specify additional locations of header files. So this would be then in here. Maybe in here, but certainly right here, I would think. So that would be like this. And no, yes, this would be, because this says home directory and this says wiringPi. Not quite sure if that is correct, but let's go right here, because this for sure now can go. This was not working out, and this would be better then, if it is correct. It's not about adding an executable, it's adding a library, and then this way would be better. Will it work out? Well, I will have to try now. So this one goes, and all I have to do is cat can make. If it works out, which I already said, so let's go. I didn't put wiringPi in here, by the way. Maybe that's not necessary, maybe it is. And have I put 2 in there? No, I have not. Oh, wait. Yeah, that's another thing. This is a variable, include anything, and this is something solid. Maybe this works. Let's just try. And maybe this needs to be hard coded. But so far, who knows? I have no idea is this going to work out. Hopefully it ends soon. Executable. Wow. It ends without a problem. Now let's see if this is working. This is working. This is also working. And now, okay. Now the question is, I have to include it in here. But here I am actually doing things. So let's change my attention to here. Where I have to add, include, not quite sure if this is going to work out. wiringPi. Most likely this has to be a bracket. I'm quite sure it has to be a bracket, but then this would be literally my home directory. So I have to compile again now. No, I said compile. This probably goes wrong. Terminated, yes. No such file directory, that is what I thought. So no, no, this is not true. Ah. Come on. Username is Ubuntu. This is true. This should be no problem. Terminated. No such file or directory? Yeah, made a typo. I made a typo. So you can see that things, when you work with colors on a black background, then things may not be as easy as you think. And now, even now, it says, even without typing or typos, it says no such file directory, which is not true because this does exist. Where to go from here? Alright, a thinking mistake and typos later. Thinking mistake was that I just needed a directory. I don't. I need the header file itself. So inside this directory there is a header file. So it's home Ubuntu wiringPi /wiringPi/wiringPi.h and mind the capital P. Then, for making sure that things do work, there's a test GPIO -v, which says, right, this works, device tree is enabled, etc. Support user level GPIO access, very nice. Read all, there you go. There you have it all. And this I can use for, as you can see, I2C, SDA and SCL. SDA is data, CL is clock. Then SPI, serial peripheral interface with master output slave input, master input slave output, clock, and data. And serial transmit, receive, and this way it should work. And that is for, I'm afraid, next time. So I can scratch this, I can scratch that. So this and this can be scratched, and hopefully now I can make steps to actually see if I can control whatever I want to control with the messages that I want to make. And by all the hassle and trying, I did not use the Mac this time, but I did use the Android tablet. Are things working? Yes. Well, via Bash anyway. And let's hope next time for nicer results. For now, thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. leave a comment or suggestion, much appreciated. You can also follow me via Instagram and Twitter. Please donate to keep the YouTube and my website with my blog going. And you can also become a patron and have your name mentioned as a supporter on my website. And depending on your pledge, also with my videos. More next time. Thanks for watching. Have a nice day and